in the example on page 57, we have a fire alarm.
Example 1. Adding digital inputs. Where's the fire? The scenario. A large building has a number of heat sensors in its fire alarm system. When there is a fire, the fire brigade needs to know where the fire is. In other words, they need to know which heat sensor has triggered the alarm. The system is controlled by a PIC device. There are 5 heat sensors, connected as inputs to port A. Port B is set up as the output port and connected to a set of 5 LEDs. If a heat sensor detects a fire, the corresponding LED lights up.
So we have these sensors which are connected to LEDs. So we're just going to use switches as the sensors and the LEDs as the alarm. So we press Control N or New Project again. We're then going to we're going to pull in an input and an output from the side toolbar into our workspace. Okay, so here's the input and the output. Okay, we're now going to create variables and I'll explain about that.
Creating the variables, right-click on the input icon and select Properties from the menu. The Input Properties dialog box appears, shown opposite. This allows us to add a variable. But what is a variable? A variable is a place where we can store information, in particular, information that changes as our program runs. In this case, it is the number of the heat sensor that triggers the alarm. It might be sensor 1 that goes off, or sensor 5. We are going to use a variable called sensor, without quotation marks, to store the information on which sensor has been triggered. Click on the arrow next to the variable box. You will see the next dialog box. Now hover over the word variables, and the arrow appears. Click on it and select Add New. Another dialog box, shown opposite, appears, offering a large choice of variable types. For now, accept the default type of byte, a variable which can store numbers from single quote 0 single quote to single quote 255 single quote. Type the name, sensor, without quotation marks, as the name of the new variable and click on the OK button. It now appears in the list of variables that the flowchart can use. Double-click on the name of the variable to use it, or alternatively click and drag the name into the variable box. You now see the Input Properties box again. Notice that you need to tell the system which port you are going to use to input the data the system needs. It is set to port A at the moment, and we are going to leave it that way. In this case, the system needs to monitor the heat sensors, and so each sensor will be connected to a different bit of port A. Click on OK to close the Input Properties box.
So the numbers went from 0 to 255. So that's like a range that where 0 is very low all the way up to 255. That range can be used for various things, like dimming a LED, for instance. But we'll do that in a later exercise. Okay, so what we want to do now is that with the output, we need to connect that as well.
Setting up the outputs next, right-click on the output icon and select Properties, or just double-click on it. The Output Properties box appears. Click on the arrow next to the Variable box. You will see the Sensor variable listed. Double-click on the word Sensor, or click and drag it to the Variable box. The Output Properties box now shows that the system is set to output whatever data is stored in the sensor variable. Change the port used to port B by clicking on the arrow in the port window and then clicking on Port in the menu that opens. Click on OK to close the Output Properties box. The flowchart should now look like this. Notice the arrows and the icon annotations. They show that information will flow from port A into the flowchart via sensor input icon, and from the flowchart via sensor out to port B output icon. Now click on the Outputs button and select the LED array icon. Click and drag it onto the system panel. Change the Count property under the Simulation section to the value $5 by clicking on the box next to the Count property and using the keyboard to input the value. Click next to Port under the Connections section to open an interactive view of the chip, showing the compatible pins. Click on the drop-down menu and select the Port B option. You have now connected the LEDs to the pins on port B.
So we have port B here, but so it was already on port B, and it shows you all the port B pins here. As you can see, RB, RB, they all start with a second letter as a B, the second letter of these is an A, the second letter of these is a C. So that's port A, these ones, port B, these ones, port C are these ones, and port D are those ones there. But we need port B for the lights or for the alarm, and for the sensor, which is going to be connected to port A, then we're going to use a switch or a switch array. So we go to inputs and then we go down to, right, there's different types of switches that we could use. We could use push switches or slider switches. So for this example, I'm going to use a slider switch, and we'll go down to switch slider, or switch array slide, and then add that. And the same as what we did here, when we click on it, the property box, move that out of the way. When I click on it, the property box is highlighted, or you can right click properties. But we want to, rather than having the 8 switches, we want to count down to 5, so that we've got an equal number of switches and lights or sensors and alarms. Now, when you go through the program with the step into and you switch on a slider, then the corresponding or the sensor, then the corresponding alarm should go. So that's the scenario of detecting a fire with 5 sensors and 5 possible alarms, and any combination in between by selecting different switches.